Hi folks, Thomas Henson here with thomashenson.com, and today I've got a very special episode for our Big Data Big Questions. We're actually going to do an interview with two of the co-founders of Streamlio. So we have Karthik and Lewis, who are going to do an introduction, going to tell us about themselves, and they're also going to talk to us about streaming analytics. So you've seen quite a few videos where we've dived in, we've talked about streaming analytics, what are some of the things that we can do with it, why is it such a popular topic? Well, let's go out to the industry and find out what the folks at Streamlio are doing with streaming analytics, and then let's also get some career tips for those data engineers with what projects you should be involved in, what are some of the skills that a data engineer should have, and then kind of what the future is like for data engineering and how to, if you're trying to search, for a new career inside of data analytics, what are the skills you should focus on, or if you're a college student and looking for maybe a thesis question, or just a way to get your foot in the door in data analytics, they're going to answer some of those career-oriented questions for us too. So find out more right after this.
Sure.
I really appreciate you guys being on. Lewis, for the second time, did you kind of want to give us some background on you, and we'll kind of go around? I just want to know, what you guys are doing at Streamlio and kind of just your background. So for the second time for my audience, I didn't press record, so.
Sure, Thomas. Again, thanks so much for having us on. So I'm Lewis Kaneshiro, one of the co-founders and CEO of Streamlio. My background is more academic from MIT, where I did mathematics with computer science and management science. Spent about in hedge funds, came back to school at Stanford and did 2 masters in management science and engineering and statistics, where I really kind of fell in love with real-time analytics and big data. And out of Stanford, I went to Udacity to teach real-time analytics with Apache Storm, which is actually how I met Karthik. And then I was the first data scientist at Shazam. And so real-time analytics and leveraging big data technologies to deliver real-time enterprise value at Shazam. And really recognize the need and really a deep belief that we're moving into an era of fast data, where real-time analytics and streaming analytics will play an increasingly important role in enterprise value. So we founded Streamlio with that belief that every industry in the world will start looking a lot more and more like finance, where data and analytics will be a driving force in enterprise value.
Okay, thanks, Lewis. I wanted to jump in and Karthik, and we'll come back to some of your background as we ask some of the career questions. But before we move on and to Karthik, I did want to ask. So when you were working at Shazam, were you there when they were doing the TV show, and did you get to meet Jamie Foxx?
No, I actually left just prior to that and the Shazam show, but both my wife and I were at Shazam earlier than that. Okay. And yeah, so I haven't met Jamie Foxx.
My daughter loves that show. She's 6 years old, so.
Fantastic.
So Karthik, this is your time. Love for you to introduce yourself.
Yeah, so my name is Karthik. My educational background is I have a PhD in computer science from what we used to call big data right now. So we graduated with PhD in big data in early to probably around 99, 2000 timeframe. So at the time, big data was never even talked about. So, but we have been doing big data from 93 onwards. So essentially, big data is what we call as what goes around comes around. So with that kind of background, I've been working in areas of both straddling in networking, where I've been working in kernel networks and networking protocols, as well as in the big data aspect of kernels, as well as how the data is being processed in either in a lazy way or a fast way, whatever might be the way that the data has been processed in some form of other, right? So then before starting Streamlio, I was at Twitter, where I was managing the real-time data infrastructure. So that is where we got a lot of experience in terms of how to manage the fast data when it comes at a high velocity. I mean, Twitter is known for real-time data and also at a big volume. So we gained a lot of experience, and we put together some kind of an infrastructure to take the data and analyze it in real time. And based on all our experiences from Twitter, and we decided to form Streamlio because of the fact that the way we were doing at Twitter is very resource intensive and multiple components, disparate components put together to get the end-to-end working. And because of that, the real-time became a big barrier for entry for other medium and larger companies who do not have those kind of expertise. And that's why Streamlio was formed, in order to reduce that real-time barrier, entry to real-time barrier, and provide a off-package solution or a service to the enterprise customers so that they can get into the real-time very quickly with a few clicks and drag and drop. And before joining Twitter, I had my own company called Locomatics. Again, that was in processing, streaming data in the location sense, and we sold that company to Twitter. And before that, I was working at Juniper Networks, where I was working on more of the Juniper routers and other things, which are still form the backbone of the internet today. So that's a brief background about me.
Okay, great. So when you were at Juniper, just kind of curious, is that kind of, I mean, you start to think about streaming analytics, and I'd definitely like to get you guys' thoughts on kind of, where some of this is coming from and so forth. But just seeing that your background was at Juniper, is that where you started looking at machine learning and some of the IoT devices before we even started saying IoT and some of those other pieces? I mean,
so we were looking like IoT in a different form. At that time, IoT, the term was never coined in the first place. Right? So, I mean, we used to have these switches and other things that are sitting on the edge or probably the remote offices, which is essentially kind of an edge. And there used to be some kind of aggregation of network traffic at the edge. And before that gets routed to the main routers or the main backbone internet, right? So there was a concept of edge and other things that were kind of understood at the time, but never in the context of IoT. And I guess probably the edge computing, IoT, and all the various terms, I believe came from the networking world. I believe it is the Cisco that coined the edge computing or whatever it is, because they were selling boxes that sits on the edge. And those boxes they wanted to promote, and they need to have additional value into the boxes. That's why the concept of edge computing was formed from Cisco's experience.
So some of the older concepts that we've had around, but we've just given names to them. Like the edge devices and IoT and some of the other pieces. So
history repeats itself.
Yeah, exactly. So, from mainframe, out of mainframe distributed systems to back to, mainframe. So, the world kind of revolves around. So, I don't think we will go back to punch cards as my dad did when he started. He's retired now, but as he started. So.
No Babbage machines. And
trust me, I have done punch cards when I was in India. And I have programmed in IBM 360. And I used to use those cards when I write the code in Fortran,
Yeah, I've heard horror stories about it. So my professor, I think she's retired now, when I was doing my undergrad, she said that what you would, the smart students, what they would do is they would teach you to take a dry erase marker or a permanent marker, and you would draw a line, so that if you were walking to the library to get your processing done, if you dropped any of the cards, you could get the line straightened back out because it was a diagonal. So. But we're not here to talk about mainframe, so sorry, I digress. But so you guys met, you were saying, around Storm. So you guys were originally heavily involved with Storm, and I guess there were some holes there, or kind of what's the story around Storm? How did you go from Storm to working with Pulsar and then creating this company Streamlio?
Yeah, so I think Twitter was original creators of Storm. In fact, it was actually created in a company called Backtype by Nathan Morris, and then it got Backtype got acquired by Twitter, and Storm became the backbone of all the real-time processing requirements at Twitter. Then Twitter decided to open source it in 2011, and the open source took off, and there has been a massive adoption of Storm in the enterprises and even in the financial communities. While it did the initial job of opening up the market and establishing the value for real time, when we started at Twitter, we found that the quality of the Storm, or the ability to operate the Storm at the scale that Twitter required, because we were pushing around 3,000 plus nodes in the overall couple of clusters. And that was causing tons and tons of issues because the system was not designed for that kind of scale. And to be specific about the issues, when the large jobs run, I mean, there's no notion of a clean way to debug if some issues, something happened with it and what went wrong with it. So visibility was an issue actually. So which means like since a lot of the critical jobs were running on the Storm infrastructure, so we used to have a lot of pagers. In fact, like on average, we used to have 10 pagers or something on those lines. So which means the pager week is a dreaded week. So then after that, like, in addition to that, there were several issues in terms of isolation, especially with respect to the fact that if multiple jobs are running together, one job should not interfere with another job, but that was not the case way it was designed. And another thing is like the ability to use minimal resources because when you have a job that is 400, 500 nodes that it has to run, when we looked at some performance numbers, we found out it's most of the time is spent on some CPU cycles without not doing much work actually. So we need to optimize a bunch of things in order to make it less resource hog and highly efficient so that we can reduce the footprint of the number of machines down itself, because that translates into millions of dollars in operation and as well as in CapEx. I mean, and these are a little bit high-level points. I don't want to go more into details. If you want, I will be happy to do it. So based on all these various issues that we have been seeing on the coming from the 60 odd teams that have been operating, we saw that like there is a need to revisit. Either at that point we had a choice whether to improve Storm itself or write a new system. So one of the fundamental architectures in Storm is more thread-based architecture where threads are being used to process various parts of the pipelines and all the various stuff like that. And if you wanted to have isolation all the way, we wanted to fundamentally go into more of a process-oriented architecture. So if we are going to change the fundamentals of the architecture, then we thought like it might not be good to go with an existing code base. Instead, it might be worthwhile to go with a new code base, and that's how Twitter Heron was started. And so then it took a development cycle of around 8 to 9 months, and we got it in production in less than a year. And we migrated everything in a year and one quarter. So essentially, this was one of the fastest projects that was done in at Twitter because of the fact that we were kind of working with a system that was highly operational. So the results once Twitter Heron went into production and after all the migration was done, the number of incidents went down by a couple of orders of magnitude. So we had probably, when I was till there at Twitter, our number of incidents were 3 or 4 at the max. And also we had a good night's sleep, and after it, because of which engineers got really productive and started adding up a lot of features that evolved the Heron over a period of time.
Okay, so we were talking about is it Heron?
Yes.
So I was looking at some of the documentation. It's still being incubated out of Twitter.
Yes. It has been officially accepted at Apache incubation projects, and now it's just a question of time to transfer the code into the incubator, and from there to go through the Apache process and graduating to a top-level project.
Okay. Well, I saw where Pulsar was incubating in Apache, and then BookKeeper that's been around. So, and that's your guys' stack. So, just kind of step back a little bit and kind of get the picture. So, we were talking about streaming analytics, and for a long time, you know, I remember when we first started out in Hadoop, we didn't have a streaming solution, right? It was just, you know, just do batch faster or break it up, do whatever we can. Then, you know, then Storm and Spark and, you know, just, you know, streaming analytics started getting there. But I felt like on the enterprise, there still weren't a lot of use cases at first, other than like, you know, bigger financial corporations for fraud detection and, you know, social media. But a lot of the use cases in some of the smaller enterprise customers weren't really there. But I feel like that's really, really being pushed here. I mean, what are you guys thinking about streaming analytics and, you know, the, you know, enterprise-wide adoption, not from just the big corporations? Are you guys seeing that more? Is that kind of what you guys are looking at and seeing?
Yeah, I completely agree, Thomas. I'd say that what was exciting about Hadoop when it first came out and the MapReduce papers was it was really taking a world that wasn't leveraging big data at all, right? If Hadoop didn't come out, then data would just be sitting around and not there would be zero enterprise value that would be leveraged from data. And so Hadoop took the impossible and made it possible, which in itself was a revolution and exciting. But at the same time, that insight was usually coming at a pace of perhaps a quarter or a week, or at some of the faster enterprises, maybe an overnight batch process. And what's exciting about streaming is, in our minds, the value of data is increasing exponentially because now insights and really real-time action is able to come when data is arriving, right? And so what that's doing is really becoming a real-time system that you're able to react to data coming in or react to situations in real time. And that's, in our minds, a revolutionary step. You're taking a batch process or even a micro batch process on the order of minutes and turning it into a real-time reaction. And so now what enterprises are doing is they're actually leveraging true enterprise value from real-time processes. And so one use case that everyone should know and all of your listeners should know is really Twitter itself. So think of Twitter and just imagine a world where each tweet that you sent out took, let's call it half an hour to be disseminated to all their followers. There would no longer be real-time conversations. There would no longer be real-time reaction. And we would live in, honestly, a much different world, perhaps, if there was no... Exactly. We'd be back to AOL, even AOL Instant Messenger was a real-time type of system. And so in our minds, the analytics, the predictive analytics that can go in at the point of, let's say, interaction with an enterprise product and an end user. And again, because of your listeners' interest in data science, what that's really doing is creating a demand for real-time predictive action, really valuing and leveraging and really coming up with new exciting use cases around fast data. And so I think we're in the very early stages of applying fast data, real-time analytics, streaming analytics, and really real-time processes to new enterprises that up until now have not gone through that digital transformation. And to be honest, I think we're living in a very exciting time, Thomas, where real-time analytics and stream processing applied to new and exciting use cases is very revolutionary.
And in addition to that, if you look at streaming, the notion of data processing as a technology, the Hadoop and other technologies belong to this class called store and process later, right? So you have to store the data first, then you process the data. On the other hand, the streaming, the paradigm is shifted where as the data is produced, where it has highest value the instant it is produced, it's immediately analyzed without even going through some kind of storage or whatever. Instead, it is going through a processing pipeline right away before it is even go to a later storage for later processing, right? So that is where the paradigm shift occurs because of the fact that the data's value is highest when it produced, and the moment it produced, you analyze and get the insights, whatever you desire right away, so that the results are instant, and that can be fed back to some kind of feedback control systems that could take preventive actions and probably even predictive actions based out of that.
Okay, so we were talking about some of the use cases and how these use cases are just kind of exploding. We kind of hinted around it when we were first talking during our introductions, but where is IoT playing into this? Is this, I mean, I did a talk at DataWorks Summit where, I think Gartner predicted 20 to 40 billion different devices by 2020. I think that's a little low. I mean, because if you look at the numbers, that's only like 3 devices per person. And personally, for me, I've got like 20 or 25. I know
Sure.
some of my friends have like 75, and then my parents still have 3 or 4, So
Sure.
I think we're wrong. Is it like a chicken or egg? Was it IoT that made streaming popular, or was streaming there and it made IoT become, a way for us to do it? What do you guys think about that?
I jump in and say IoT is exciting, definitely for the new use cases around smart city, actual devices, anomaly detection, edge computing, fog computing. All of that, what it has in common is, just massive amounts of data that up until now just didn't exist. And so as data is generated and being predicted to also grow exponentially, we're seeing an exponential rise in data at IoT. And not only that, but just imagine if all of this IoT data, for example, sensification of, let's call it a bridge in a smart city type of application that's helping to regulate traffic flow. In a batch first world, that data would simply be stored and maybe analyzed overnight. And the only insight that could come out would be to say, earlier today, you probably should have routed traffic in this different direction. Whereas now, again, this exponential value of growth of real-time data what it allows us to do is take vast amounts of data, analyze it in real time, and then have a real-time action. For example, rerouting data in real time to optimize energy usage and fuel costs. And so IoT, it would be one definitely exciting use case that we're seeing. It's definitely a future direction where real-time analytics, vast amounts of data and specialized systems that will unify messaging, compute, and stream storage all come into play. But I would say that it's just one. Social media would be another real-time existing use case that I think, for example, at Twitter, these systems had to be really invented and perfected and optimized because social media data and Twitter especially was a pioneer in reacting to real-time data at scale and in real time. And so there's many different uses, obviously in finance, obviously in security, that can use real-time and streaming analytics. And that's only the real-time use cases. If you really look at the fabric of data as well and fast data fabric, within an enterprise, you're seeing new architecture paradigm of microservices that's bringing in massive amounts of data internally in an enterprise in order to react to data also in real time with existing data coming from multiple different sources. And so you're seeing an explosion of real-time use cases. You're seeing a reinvention of existing architecture that's leveraging streaming architecture. And all of these use cases and directions is really, in our opinion, the future and where Streamlio sits.
Okay, yeah, and so one of the things that you brought up there was around the microservices, and I was looking at your website and kind of going through some of your documentation, and I see a lot of around containers, and so I've kind of coined in the last couple of years, that there's a containerization of the world, but traditionally for when we think about Hadoop and analytics, I remember when I first started out, and I just asked the question about virtualization. It's like the third rail. We couldn't do it back then, right? This was Hadoop 1.0, maybe even 2.0. But now, fast forward to some of the changes that are coming out with Hadoop 3.0, and kind of you're seeing them make more way for containerizations. Were you guys built? I mean, since you guys are fairly new, were you guys built upon containerization and had that in mind? And kind of explain that a little bit.
Yep. I mean, already when we started, even though at Twitter, we never had this notion of Docker containers and everything when we had our infrastructure. But there was a notion of C groups, if you know very much in Linux, right? So that was kind of what we call as a poor man's containers. So that capability existed in Linux for some amount of time. And we were taking advantage of that in order to provide some kind of isolating capabilities when large jobs are running alongside other priority jobs and alongside with some critical jobs, right? So that's the only way we can isolate so that one job does not interfere with another job. So when we started Twitter Heron and all, so we said we are going to be in the container world in the next 3 or 4 years. So we should exploit what the containers provide. In fact, all the terminologies that we use within Heron itself, hey, how many containers do your job run? hey, like my job runs 100 containers, 200 containers. In fact, we use the term container in order to make what you call a unit of work. One part, so a job consists of multiple containers, and one container is doing some single unit of work. So, and all the containers collectively do the entire processing that is required. So right from the start, we embrace containers so that as we move into a container world, we will be a natural fit into those world. So that like with the advent of Mesos supporting Dockers and Kubernetes coming up in a big way with Docker containers, we are very native to run in those kind of environments.
Okay, and then so you guys, you guys, I see that you guys have support to run in the cloud, but also premise. So your sandbox, people can go out and download, and they can install it and run it on premise. They can run it in AWS, Google Cloud. Is Azure supported as well?
So the direction that we've taken is really to optimize on Kubernetes. So Heron within Twitter was running natively on Mesos and Aurora, and when we started Streamlio, we just saw such massive adoption of all of our prospects and customers of Kubernetes that we basically took a very early bet that said Kubernetes would really allow us to seamlessly work on-prem, any cloud provider, and also at the edge. To us, the edge is simply a very small data center, and as long as Kubernetes, is sort of installed, what we do is really have a one-line install command on kubectl. And so we're really leveraging that capability to allow us to be a seamless fabric. And so, as you know, Azure is also supporting Kubernetes, and therefore leveraging that system, it becomes very simple for us to be this transportable, fast data fabric, both in the cloud, a hybrid cloud, which is a very common paradigm we're seeing with customers, on-prem and at the edge. And so we really believe that's the future. And what's exciting is very early on with Heron and Streamlio as a company, we optimize for that, and we're seeing the dividends pay off with very easy installation and management.
Wait, so I want to switch gears a little bit. You guys got about 5 more minutes and to switch, and we can roll into some. I want to ask some career questions, if you don't mind. Is that okay with you guys? You guys still have time?
Absolutely.
Okay, great. So a lot of the people that watch, we do a segment called Big Data, Big Questions. A lot of questions that I get in are from people who are maybe, been in IT or enterprise development for about 1 to 2 years, but they want to get around and get involved in big data projects. Or there's some people that are students or looking to maybe change, make a career change. And so I just have a lot of questions that I see repeated all the time. But I mean, you guys are co-founders of a company. You've been, both of you, heavily involved in the big data analytics ecosystem even before it was big data. So just had a couple generalized questions that I think will really help out some of those students. So we talked a little bit about your background, but I want to say what do you think are the most important skills for data engineers now? So here we are, 2018. What skills should they be looking to acquire to be able to be employed by companies? You guys talk to enterprises. What do you guys see?
Sure. Yeah, so I think I've been teaching at Berkeley also. So, whenever I get time, I teach undergrad course in database at Berkeley for the CS department. So, a lot of people, students, when they come and join the school, they get enamored by the machine learning, deep machine learning aspects of it. But one of the challenges that we face as in the enterprises and in the companies when they go to work after they graduate is that data engineering is probably stake to 60 to 70% of the time. In other words, the data has to be moved to the place where the analysis has to occur before the analyst or the data scientist or whoever the students who are trained to be more data scientists can do the job, right? So one of the advice that I give to the students is you should be knowing all of the stack. In other words, you should focus on data engineering so that you know how hard it is to get the data and cleanse the data and move the data to the place where you like to. And then when you analyze the data so that you have an appreciation for how the data gets there, then when you analyze and get the insights, that is the next step where you really add value in terms of more on the enterprises. So most of the time when I see students, they are focused on either one of them, but not have a knowledge which straddles on both those areas. So so the next thing that I would advise is the students that recently graduated, they do not have in-depth knowledge about the data processing techniques, how the data has to be processed, what are the underlying system trade-offs and other things that people have to know so that they can tune themselves without the help of others. So that kind of skills is missing actually. So most of the students just take some high-level Java courses and then suddenly move into data scientist without doing the hardcore systems lifestyle courses where at Berkeley and all, what we used to do is when you take an undergrad database system, people are asked to implement the parts of a database system so that they know the internals and how the thing works. And similarly, also implement some parts of the distributed systems like Hadoop so that they know how those systems work underneath, right? So those kind of skill set is what they need to acquire in order to make what do you call when they go into a data carrier or a data scientist or / data engineer, they can make a huge difference. And that would be my advice.
Yeah, that's an interesting point because I kind of see it and I get a lot of questions, and so I come more from the engineering developer operations side and not so much on the data science, but I get a lot of questions around how much do I need to know for algorithms and making those decisions? And, from my perspective, I didn't see that, I didn't make those decisions, but I still wanted to know, like, I needed to know how to use my how, right? But I didn't need to know exactly like, what variations and how I was going to tune it. I needed to know how to do it, but our data scientist, he was going to know, what we needed to implement. And when we went to implement it as a data engineer, my role was to be able to make those changes in my how and have that whole operations kind of running. So more on the implementation. But you're saying that you're seeing even data scientists come in and they don't have some of the basic knowledge or basic, hey, this is how it's going to work from a Hadoop perspective. So it's kind of a blended from both sides, right? You have your engineer and you have your data scientist. So.
Mm-hmm. Yeah, Thomas, I definitely say that the data science direction, data engineering direction for your listeners is blurring. It's definitely sort of converging, and for your listeners that are more data engineers and she's wondering, what do I study to become a data engineer? As Karthik's saying, yes, studying from the ground up allows you to understand when things go wrong. And I think the mark of a great data engineer is that, sure, there's technologies to learn, but when something goes wrong, you always kind of point to the person on your team or the person in your network, or maybe it's yourself that understands the deep issues that come up and show you the one to go and solve the problem when no one else on the team can. And a lot of times that comes from experience or deep excitement and interest in understanding that underlying technology. My direction is more on the data science side. And so I'm excited about what you can do with data. I'm excited about the applications you can build, the predictions you can make, everything you build on top of systems. But as a result, you brought up algorithms, for example. That's the part of the world that I get excited about. And as you can hopefully hear, I'm extremely curious and excited about the future and am excited to learn more. And so my biggest advice is learn how to learn. And that seems a bit circular, but the more you learn, and if you're excited about learning new technology, when I first started at Shazam, maybe some personal history, but I'm coming out of 2 masters at Stanford. If you've ever heard of Stanford, it's you expect to come out of Stanford with sort of the entire tool set
and
to really land a job, right? But at Shazam, we were using data technologies that Stanford was still trying to catch up on to teach, right? Spark, Pig, Hive, Hadoop, all of these big data terms I learned on my own outside of school on weekends. And the algorithm parts and R, for example, and the data science part and proofs, sure, all of that was in school, but really that excitement to learn and go out and whatever is the best tool for the job, go and learn it and ask people the right questions, but be curious and try to figure out how to get there. And that I think is the data science side of me. And if massive problems come up with an implementation detail and the Stack Overflow trace and things like that, know when to ask questions, and that's all part of learning how to learn.
Yeah, no, I couldn't agree more. It's probably been 5 or 6 years since I finished my master's, and I still pay for my own extra education and spend a lot of time. So sites like Udacity, and then I'm a Pluralsight author, and just reading blogs and catching up with what's going on in open source. Because it does. I don't think any job. This is kind of outside of just IT. I don't think any job anymore you're going to be able to just to have it, and all the knowledge that you got in college or when you first got on the job. We're going to continue to have to learn and take responsibility for that.
Sure, I couldn't agree more. And we're living in a world that's changing rapidly. And being a lifelong learner as a data engineer, as a data scientist, or really any, I would say, technology career, but really any career, once you embrace lifelong learning, really you can become whatever you want. And I think that was extremely motivating and really part of the inspiration of why I wanted to join Udacity in the first place. When I joined, we were really pursuing free education scalably for the world. As people were transitioning from, different industries into technology, we were trying to really give students and learners access to education for free, and MOOCs and massive open online courses, obviously. And so, here at Streamlio, we're really trying to educate a new paradigm of computing as the world is moving from batch to streaming. Look at the number of streaming data engineers or streaming data scientists, which are even a smaller subset. And if true enterprise value is coming out of streaming in real time, how is the existing workforce going to learn this? And so we've really been dedicated to providing free education to individual developers. And if you visit our site, you'll see the pace of education that we're presenting, not only to learn about our platform and how to use it and how to apply Pulsar, Heron, BookKeeper, and really Streamlio platform to existing enterprise use cases, but really how do you learn about streaming? And anyone with that lifelong learning mentality, there's ample free resources out there. And look, technology will constantly change, and there'll be new algorithms to invent. And that idea of having a static degree from any university that's going to follow you for the rest of your life is just an outdated concept. So, we really hope that we're a great partner for educating this new generation of engineers of science.
And in addition to that, one of the points architecture, the instruction set, and the trade-off between memory, networking, and storage, and the CPU. So the trade-off is just shifts. So that is the fundamentals of the computer science, right? So once you understand these fundamental concepts, then the other things are more what do I call as a different way of data processing. But that concept is just going to twist that fundamental computing concept in one way versus the other, right? So if you understand the code, then you understand the trade-off, what that trade-off that system is making versus this trade-off, right? So that way, what happens is once you get a strong fundamental of the core, you can keep moving, as Lewis pointed out, keep investing on the new learning. The learning part gets reduced because the core concept is still the same and is stretched in a different way, and you just have to learn the lipstick of that system, right?
Or I would say, again, lifelong learning, and let's predict the future, right? Sure, GPUs, right? So GPU computing, let's call that a paradigm shift. Let's go further and say quantum computing, right? What is the, when does PGP and cryptography sort of fail when quantum computing comes up and Schur's algorithm, and now we have constant time cracking of fast factorization of large primes. And what about blockchain and blockchain technology, leveraging worldwide computing? And so, it all depends on your time frame. learning and incremental learning of new systems. There'll always be a new open source system or closed source. There'll always be made up names and new ideas. But when do we get into that punctuated equilibrium, right? Going back to that evolutionary concept, when the world is going to change, and the world changed a lot with Hadoop and big data. We think the world is changing again with streaming, and definitely Streamlio is a dominant player in that space. But when will the world change again with quantum computing and change? Maybe it's changing now with blockchain as a technology. I'm not saying crypto coins and things like that, but really blockchain. So we are living in such an exciting time, and what I love about that is we will always be living in exciting times. There'll always be something exciting to learn, and so again, it goes back to that lifelong learning concept. As Karthik's saying, learn fundamentals because then you know when to break the rules. Very very artistic in that sense, like Picasso, right? When he was a young child, he learned to paint and draw like the masters. And then he changed it and created a new style, and that required core fundamental knowledge in order to bend the rules.
Well, this has been great. I really appreciate it. It's such an exciting topic to talk about because it's new and it's emerging, and I mean it's changing every day. But just thanks for you guys' time. One last thing. So if people are watching this, they want to get involved and play with Streamlio, and what's the best way for them to do it? I mean, should they check out the open source projects, go to Streamlio to your website and download your resources? What would you like to people to steer towards?
We've definitely made a commitment to free education, and so visit Streamlio, which is streaml.io. We have a learn section, a blog section. The pace that we're pushing out content is really coming from demand. We get a lot of questions about certain aspects of the technology, and then we'll generate a blog, a video that's really targeted to both new users and more advanced topics like total ordered atomic broadcasting. We go as deeply and really free education, graduate level education that's coming from decades of very unique experience and pioneers of enterprises, all the way down to how do I install this, with one-click command on GKE. So, really lowering the barrier to entry for learners that have the desire and the motivation. And that's what you bring, and we would definitely welcome exploration there. We have public Slack channels on each of the underlying projects as well, and really there's a lot of information off Streamlio.
Okay,
a lot of information. We have even published academic papers in premier conferences as well too. So if anybody is the grad students who are interested in looking at those papers, or if you are interested in doing PhD thesis on this topic, just ping us to us. We have a lot of topics available.
Sure. We actually had our first successful Stanford PhD defend his thesis, which was about half on heron.
Oh, that's great.
That is exciting from definitely academic graduate to put in production at enterprise, all the way down to the new learner.
Oh man, that's great. Well, I'll link to all this in the video and then also in the show notes. But thanks again for you guys' time.
Great,
Thank
Thomas.
you.
Thanks again for having us.